to be here. I'm a movement disorders neurologist at the University of Michigan, and one of the conditions I see involving the brain is Huntington's disease. And just thinking about what to say here, I know many of you are here because you know the Elis, or you have other friends or family with Huntington's disease, and so this is probably personal at some level for many of you. You know, whether it is or isn't, I think we should all really care about Huntington's disease, and I think there are a number of good reasons for why we should care. And I think, you know, I mean, to start with the basic facts about the disease itself, I think many of us are familiar with. It's a genetic disease that affects the brain, and if we think about the human genome, that is all the genes that make up our DNA, we each have about 20,000 genes, and these are little coded blueprints for every protein that makes our body, and we inherit a version of each of these from our biological dad and from our biological mom. And so each of these genes, we get one each from mom and dad, and there are 20,000 of them. So, you know, you're talking the number of genes is about similar to the number of people in a stadium. And this makes us who we are. Now, in the case of Huntington's disease, there is one of these genes, and it's called the Huntington protein. It's actually named after the disease. We all have the Huntington protein, but those of us who have a normal gene, the Huntington protein does what it's supposed to do normally our entire life, and that's that. If you happen to have Huntington disease in your family, there's one stretch of the code for this protein, and this is in the DNA, one stretch where there's just a few too many what we call base repeats. So the code is sort of in letters with nucleic acids. So CAG, 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 and we all have a certain stretch where that just repeats over and over in this one gene. And maybe those of us who don't have this have 17 from our moms and 21 from our dad, or something like that. And life goes on as usual. If you inherit the gene mutation causing the disease, instead of 17 or 20, you might have 37 or 42. So that seems so silly. I mean, it's just 20 extra base pairs in one protein out of 20,000 genes that make up our total blueprint. Just one. But what do we get? So if you get this, if you have this, people who get this don't choose it. People who have it, who have children who get it, don't choose to pass it on. But when you inherit this, at some point in the middle of your life, you start to experience changes. And this is because brain cells, not all of them, but some ones in pretty important areas, begin to degenerate, and the millions and billions of connections that we have within our brain, there are some regions that start to break down. And the result is people have subtle changes in personality, mood swings, slow thinking, difficulty processing information, and physical changes, which we can see as in coordination, characteristic involuntary movements called chorea, clumsiness, gait difficulty, and unfortunately over 10, 15, 20 years, sometimes longer, sometimes less. A lot of it depends on, to some degree, luck and general health and exercise and all of that. This is a fatal disease at this time. So it's you know, obviously it's a devastating disease, and it affects not just patients in the middle of their life, but it affects entire families who often, there are young children watching a parent go through this. There are children who are thinking about, well, might I get this when I grow up? There are parents who are worrying about their children. There are grandparents who are worrying about their grandchildren. So the sheer level of concern and implications for a family that is suffering with this is just monumental. And I'm a neurologist for this disease, but I still really, I'm in awe at the spirit and the fight and the constant uphill battle that these folks are fighting. And in many cases, even though the disease is ultimately taking over things and weakening them, the human spirit somehow triumphs. And I think tonight is an example of this. So the foundation obviously has a great mission, which is to help families that are in this situation with some basic needs, some basic things to make life easier. Respite care, providing funds when it's needed, home modifications. I mean, just little things that can make a huge difference in this extremely stressful journey. And it's really a pleasure to be here. So the couple of things that I will add as to why else we should really care about this is because of where we are in time. So the year 2016, what I've told you about how we understand the origins of this disease, nobody even knew 30 years ago. So this was not known. Now, there are other brain degenerative diseases that many of us have in our families. Parkinson's, Alzheimer's. Many of us will get a brain degenerative disease when we're older. And so we should care for Huntington's disease because this is an example of one disease where we know the cause. And so researchers right now are looking at Huntington's disease as a prime example of something that, well, if we can figure out how to fix this, because we know that it comes from this little coded abnormality in the gene, we can learn a lot about this that would help everybody with whether you're at risk for Parkinson's or Alzheimer's. This could be a window to a whole new area of medicine. And this is why I think actually Huntington's disease stands out in medical training. When medical students are learning about genetic disease or neurologic disease, there's always cases of Huntington's disease that are being presented as examples because it is so important for society to understand a condition like this. And I think where we are with research on this is actually very hopeful at this time. So there are now early clinical trials for taking a little stretch of human-made nucleic acid, so that is sort of a false code almost, and introducing it into patients who have early disease or might be at risk for it, with the idea of, can this go and block the expression of the wrong code, of the expanded code? Could it go and just shut that gene off? And the proof of concepts for this have happened in animal studies, and so this is now being developed to, okay, let's just see if this can even be safe in humans, and this is just beginning. And I'll say 6 or 7 years ago, it was all a theoretical idea, and it's kind of exciting now to see that this is where research is going. But really, an event like this is one small but critical part of the whole fight against Huntington's. And I'll close by saying that what I've told you before, which is, folks who participate in clinical trials and research, to me, they are like volunteers. They're like soldiers in a war, and our society, justifiably so, we idolize the men and women who serve and fight against our enemies. And I think people who participate in a clinical trial and stand up and say, we're going to try to do our part to tackle this disease head on, are marking their spot in history, because the sacrifices, the things they do, the time, the effort, the risk, all of that is in the end going to make a difference and make us lick this thing. So, thank you. It's my pleasure to be here.